Greetings. I am Dr. Jeff Matthews, astronomy professor at Foothill College. It is my pleasure to welcome you, both the folks who are in person here at the Smithwick Theater and the people who will be viewing this online. It is my pleasure to welcome you to this fifth talk in the 23rd year of the Silicon Valley Astronomy Lecture Series. This series is sponsored by the Foothill College STEM Division, the SETI Institute, so that's the Search for Extraterrestrial Intelligence, the Astronomical Society of the Pacific, and the University of California Observatories. The goal of this talk series is to present current work and discoveries in astronomy in everyday language. And so our speaker this evening is also the founder of this series. Andrew Fraknoi has dedicated decades of his career to the public communication of astronomy and education in astronomy. He was the executive director of the Astronomical Society of the Pacific, dedicated 25 years of service to teaching at Foothill College. He's now teaching courses aimed at retired people at the University of San Francisco and San Francisco State. Andrew has carried out many dozens of radio and television appearances explaining astronomical discoveries in everyday language. He was the lead author on the free OpenStax astronomy textbook, co-author of Solar Science, a book for educators, and the author of a children's book, When the Sun Goes Dark. Andrew has also won honors in the field of astronomy for his outreach work and education work. He was named the California Professor of the Year in 2007. And the International Astronomical Union has named asteroid 4859 Asteroid Fraknoi in recognition of his work in astronomy outreach. For the 2017 solar eclipse visible in North America, and for the upcoming eclipses, Andrew has been one of the leaders of an effort to distribute millions of solar viewing glasses. I suspect he might be discussing this effort a bit this evening in his talk. So, Andrew, I'll stop stealing your thunder on that one. So, Andrew will be speaking tonight about the 2 solar eclipses that will be visible from North America over the upcoming year. He'll be explaining why eclipses happen, where to go to see them, and how to observe them safely. So, with no further ado, I would like to ask you to join me in welcoming Andrew Fraknoi.
Thank you for that wonderful introduction, and thank you all for coming out and missing perhaps the most exciting basketball game, right? But we appreciate your preferring astronomy to sports. So let me get right into our discussion tonight. You did hear that I put together a reading list and a resource list, which you should have on a yellow piece of paper. So I'll be mentioning a number of resources you can get free tonight, and all of those are given on that resource list that you have, so you don't have to quickly write them down. So let me begin by just saying that it's pretty rare for a country to get 2 interesting eclipses in a row within one school year. And we're very fortunate, having just had in 2017 a pretty nice total eclipse, to get another total eclipse so soon. So I want to join with you in celebrating this celestial coincidence and to tell you more about what to expect. We're calling it the eclipse doubleheader. Here you see the paths of the 2 eclipses. They cross in Texas, and they go on and are visible in other countries as well, in Central and South America and in Canada for the other one. So I'll talk more about that as well. What's an eclipse? Well, an eclipse is when the moon covers the sun. And it's a remarkable coincidence that as seen from Earth, the moon and the sun happen to be the same size. The sun's a lot bigger, but it's further away. The moon's a lot smaller, but it's closer. And it just works out. So this is not true, we figured out, on any other planet. When you look at the planet-moon combinations on any of the planets in the solar system, we're the only one where the moon exactly covers the sun and makes total eclipses possible. If you don't believe me, here's an example of total cosmic failure on Mars. This is the moon Phobos on Mars, which has the shape of a diseased potato, trying to cover the sun. And you can see it's a pathetic attempt. It can't cover the sun. So we are really lucky to be living at a time and in a place where total eclipses are possible. And I hope to make you appreciate why they are so special as we go along. So this is what a total eclipse looks like when the moon fully covers the sun. The outer atmosphere of the sun, which is usually completely invisible to us, becomes visible. Some of the activity, the explosions, if you will, of great hot material at the edge of the sun become visible, and the day turns into night. Because the sunlight is gone, birds and animals get all confused, and it's an absolutely eerie spectacle to see the darkness in the middle of the day, which happens during a total eclipse of the sun. So here's the celestial lineup. The moon gets directly in front of the sun, and its shadow then makes a spot on the Earth. Because the Earth turns and the Earth moves in orbit, the effect is that that shadow spot moves as time goes by, and that dark shadow makes a path across the face of the Earth. If you're in that path, you can see the full eclipse. If you're outside that path, you still get to see often a partial eclipse. And I'll show you who gets to see what in the ones that are coming up. There are three ways that the moon and the sun can align for us. And here they are. If the moon is exactly in the right place, it will completely cover the sun, and we get that beautiful total eclipse that I just showed you. But the moon's orbit is not a circle. It's actually a little bit of an oval, and that means sometimes the moon is just a little too far away in its orbit to fully cover the sun, and it leaves a ring of fire when it covers the sun. A ring is also called an annulus, so we call this an annular eclipse, when you can see a ring of fire around the dark face of the moon. And then if the alignment is not good, if the moon's orbit has carried it below or above the sun, or if you're not in the right place on Earth, you get to see a partial eclipse of the sun. And this is what the three look like. The total one with the atmosphere of the sun coming up, the annular one where you see this beautiful ring of the sun around the moon, and the partial eclipse where you see a bite taken out of the sun. Now, if you don't believe me that this is what's happening, I brought proof in the shape of a picture taken from space where you can actually see in a past eclipse the moon's shadow, the dark round shadow of the moon falling on the surface of the Earth at that particular moment. So this is the picture we generally have of the eclipse. We don't always have perfect weather, and we'll talk about that in just a little while. And so in this situation, the eclipsed sun happens to be visible, but with clouds threatening. And what you're seeing there is the diamond ring effect. When the moon is about to cover the sun, the last little valley on the moon allows the last little bit of sunlight to go through, and you get that flash of light that looks like a big diamond on a ring. So that's the last thing you see before a total eclipse. So let's talk about the two eclipses that are coming up and get into more detail. On October 14th, 2023, so coming up in less than 6 months, we're going to have an annular eclipse. And this is going to be on a Saturday. So any teachers here, you're going to need to prepare your class beforehand because the kids are not going to be with you on the actual day of the eclipse. It's an eclipse which is visible especially well in the western United States. So we're calling it the American West Ring of Fire eclipse. This is the sequence of events during such an annular eclipse. You see the moon slowly covering more and more of the sun and then just leaving that ring behind. As long as any part of the sun is showing, it's dangerous to look at the sun with your naked eye, but you all should have, those of you in this auditorium, should have a pair of eclipse glasses with safe material so you can view the sun even when it's completely out or when it's partially eclipsed, as it is here. Those of you at home, those of you watching on YouTube, I'll have more to say about how to observe the sun safely if you don't have these glasses later in the program. All right, so this is the path. And again, if you're not able to see the details of this map, it's okay because I'm going to tell you about a free booklet that you can get where this map is printed in nice detail and you can study it at your leisure. But the eclipse comes in Oregon. It's not visible in Portland, but it is visible in Eugene. So if you have any friends or relatives in that part of the state of Oregon, now's the time to remind them how much you miss them and how much you'd like to have an invitation in October. The eclipse then goes down toward the southeast. It goes through New Mexico and a number of other towns and then comes out on the east coast of Texas, as the Gulf of Mexico. Let's take a look at some of the places where the eclipse will be visible as a ring of fire, as an annulus. I mentioned Eugene, Oregon, Winnemucca, Nevada, Albuquerque, New Mexico, Roswell, New Mexico, which is the UFO capital of the universe. They think they've had a UFO landing. Believe me, they have not. They got mixed up with an old Defense Department crash. But that's a story for another time. Odessa, Texas, San Antonio, Texas, and then on to Central America. So if you're in one of those places in the morning of October 14th, you'll be able to see this ring of fire around the dark sphere of the moon. Here's a map of Oregon, and it shows you the closer you are to the center of the path, the longer the eclipse lasts. So again, these maps are all available on websites, which I will tell you more about, and which are on your resource sheet. But Eugene, Oregon is a nice place for you to go. It's a university town and a good place to see the annular eclipse. But here's the issue. In October, the United States often has cloudy weather. And so this is a chart that shows you what fraction of the time it's cloudy on a typical October day. And the lower the city is on this graph, the less likely it is that they'll be cloudy. The higher it is on the graph, the more likely it is to be cloudy. So you can see that the problem with Eugene, Oregon, is that the likelihood of clouds is pretty good, and that you need to go east of Oregon, east of California, and find places where the likelihood of clouds are lower. Albuquerque, for example, turns out to be pretty good in terms of the predicted cloud fraction. So if you're planning to watch an eclipse in person, it's very important to pay attention to the weather as well as to the astronomy. Here's what the eclipse in 2023 will look like in major U.S. cities. In New York, for example, it'll only be a 35% coverage, but in Los Angeles, 78% of the sun will be covered. In Houston, Texas, 90% of the sun will be covered. And I'll mention what's happening here in the Bay Area in a minute. Washington, D.C., we're going to have a 42% coverage, which is pretty much the typical cover-up in Washington, D.C. No, I didn't say that. Here's the situation where Foothill College is located in the San Francisco Bay Area. 83% of the sun will be covered. The eclipse begins early in the morning, 8:05 a.m. It's at its maximum at 9:20 a.m. and is over before 11. That means if you're going to watch this partial eclipse here, you need to get up early in the morning and go somewhere where you have a clear view toward the eastern horizon, because the sun will just be rising in the east, and you need to be able to have no mountains, hills, tall buildings, trees, chubby neighbors in the way. You need to be able to have a clear view down to the eastern horizon. So make sure you pre-plan your eclipse viewing by going out the day or the week before and getting a good sight line in the morning for where the sun is rising. All right, now if you want to know where the eclipse will be visible and how much of an eclipse you'll have in your particular location, I recommend a website called Time and Date, www.timeanddate.com/eclipse. And for each eclipse, they have a separate page which you can go to from this general eclipse page, and then you can put in your community, no matter how small it is, or your favorite national park, and it will then give you all the information you need about what that particular eclipse will be like in that particular location. So it's really a useful website to go to if you want to see, or if you want to tell your relatives what the eclipse will be like for them. So that's the warm-up, that's the appetizer. But now I want to tell you about the main event, the main course, which is the total eclipse that's coming up in less than a year. On April 8th, which is a Monday, so it will be a school day, of 2024, we will have a total eclipse of the sun. They're calling it the Great North American Total Solar Eclipse because it's not just the United States, but Mexico and Canada are also participating in that path where the eclipse will be total. This is the sequence of events that happens during a total eclipse. The moon more and more covers the sun. There's that diamond ring effect that I showed you earlier, and then in the center you see the beautiful total eclipse with the sun's corona, its hot atmosphere, becoming visible in the dark sky. So this is going to happen on a path which goes from Mexico up toward the northeast into eastern Canada. And this is an eclipse map for true eclipse fans. If you are an eclipse devotee, a partial eclipse won't do for you. For most of us, a partial eclipse is an exciting event. But if you're a fanatic about eclipses, you have to be on that path. So this is a fanatic's map. What is the eclipse like in different parts of the country? You can see lines with the percentage of the sun eclipse, but everywhere the true fan has said, nope, 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 nope. And only on that line, on that path, is the eclipse really worth going to for the true believer. And you can see the three countries are indicated by the three phrases on the eclipse path. Here is a better map of where the eclipse will be total in the United States. You can see that much of Texas will get the eclipse, not all of Texas, but a good part of Texas. And then the eclipse goes northeastward through Indianapolis and through much of the northeast states. New York, for example, Niagara Falls will see a total eclipse of the sun. So if you want to have a really special wedding, now's the time to start. I'm sure they're all sold out by now, but Niagara Falls is available as a spectacular wedding backdrop. And then the path moves northeastward into Canada. There are national parks in both eclipse paths. The annular eclipse path has a lot of national parks in it. And I'm going to tell you in a minute where you can get these maps, so you don't have to memorize this map. But there are a number of national parks in the total eclipse path where you can make reservations and have an amazing camping experience. The places where the 2024 eclipse will be total include Mazatlan, Mexico. So if you have any rich people who have second homes there, again, try to remind them how much you love them early on. And then we come near San Antonio, Texas, Dallas, Texas, Little Rock, Arkansas. Not in all of that of each of these towns, but only in parts or regions near those towns. Indianapolis, Cleveland, Niagara Falls, Buffalo, New York, and then on to Canada. So those are some places you might want to go, but the further north you are in April, the more likely it is to be cloudy. So once again, you have to put the cloud fraction into your calculus when you're trying to figure out your trip. And again, you can see graphs like this, where it shows you the lower a city is on this graph, the more likely it is to be clear. The higher it is on a graph like this, the more likely it is to be cloudy. So you can see that many of the places in the Northeast are going to be a problem for eclipse viewing, because the chances, for example, in Indianapolis will be almost 70% of clouds, whereas in Mazatlan, Mexico, it will only be about 25% chance of clouds. And I want to mention that Texas in the United States is probably one of the best places to be. You may be politically allergic to such a trip, but it's really good for eclipse viewing. So again, these maps are available on the web. I want to show you the path through Mexico briefly. You can see that there are a number of coastal towns and then inland towns where you can situate yourself. You need to check about security in each town that you go to and their ability to service a lot of tourists, because many, many eclipse fans from around the world will be descending on Mexico. Then as you go through Texas, you can see that near San Antonio or Austin, there are short trips you can take and good highways, freeways available where you can get near the center of the eclipse path, where you will have the longest total eclipse experience. The more you are in the middle of the path, the longer the eclipse lasts in that particular location. And again, Dallas is in the path, but you can take a short trip from Dallas to get to a place near the center of the eclipse path. Where did I get all these maps? Well, it turns out there's a wonderful eclipse website put together by a professional map maker, Michael Zeiler. It's called GreatAmericanEclipse.com, and I can't recommend this highly enough if you like maps or if you really want to figure out where to situate yourself. All the maps that I'm showing you were stolen with permission from GreatAmericanEclipse.com, so I recommend that. What will the eclipse be like in major cities? Again, depends on how close they are to the path of the eclipse. For the total eclipse, New York will have a 91% eclipse, but Los Angeles only a 58% eclipse. But you can see that there's a substantial partial eclipse, a big bite taken out of the sun in many major US cities. And so traffic and business will come to a halt during the time of the eclipses. Here in the San Francisco Bay Area, we'll have a 45% cover-up. And it's, again, a morning eclipse, not as early as the annular eclipse. We'll start the eclipse around 10:14 a.m. The maximum eclipse will be around 11:13 in the morning, and it'll all be over right after noon. So there you don't need to have such a good view of the eastern horizon. The sun will be higher by the time the eclipse occurs. All right, so we started to calculate, if you include partial eclipses as well as the total and annular eclipses, how many people will be able to see some kind of eclipse in the next school year. And the number is, pardon the expression, astronomical. It's 500 million people will potentially be able to see an eclipse during these two times. For an astronomy teacher, this is an amazing opportunity and an amazing challenge. How are we going to get 500 million people ready? Well, not all of them are going to bother. Many of them will be busy at work. Many of them don't care. But still, we expect with media coverage these days and so many social media, there will be enormous interest in the eclipses roughly 2 or 3 days before they happen. That's when most people catch on. You're way ahead of the universe by being here tonight or listening to this video early, but most people won't know about it till it's just about to come, and then they're going to have to deal with how to view it for themselves. You'll have lots of time to prepare. But as we thought about this, we said, oh my goodness, how can we get information out? We had the same issue in 2017 when there was an eclipse visible from the United States. Whenever any part of the sun surface is showing, it is not safe to look with unprotected eyes. Even that little ring of fire in the annular eclipse, if you allow that much light to hit your eye, it can damage your eye. And so we need to make sure that everybody, no matter what age they are, is properly protected. Here's a young eclipse gazer all ready for the eclipse. And that everybody's educated. In 2017, despite our best efforts to educate the country, there were some people who were, pardon the expression, left in the dark or in the light and looked up at the eclipse without proper protection. We won't name any names. We'll need lots of safe solar viewing glasses, lots of information about other ways of viewing, and we began to think, where is it in each community that we can get information out? And we realized that most communities have an information distribution center built into the community, the public library. So it hit us in 2016 that we ought to engage public libraries in eclipse education. And we were able to persuade a foundation to fund glasses to be sent to public libraries around the country, not all of them, but a number of them, and to have them distribute glasses and information. And that worked so well that the same foundation has made an incredibly generous donation today. This is the Gordon and Betty Moore Foundation, and they have agreed to fund 5 million eclipse glasses to be distributed free through 10,000 public libraries nationwide. So I'm really thrilled about that. We're working on this project through the Space Science Institute in Boulder, Colorado. Many libraries have already signed up. We have over 6,000 libraries that have already signed up and are getting their glasses. If your library is not signed up, now's a good time to tell them about it. And then we hope that the library will not just distribute glasses, but will also have eclipse events, as many libraries did in 2017, to tell people about eclipse science and to tell them about the safe viewing of eclipses. If you have a library that needs to get informed about the project, here's a short address they can go to, bit.ly/glasses for libraries. And it's not too late for a library to sign up. We have produced a guide for librarians and the public. Many librarians have no background in science. Why should they? So this is a non-technical guide to the 2 eclipses coming up. All the maps that I showed you, the charts of what happens in each cities, are available in this guide. And you can find this guide free of charge. You don't need to be a librarian at this shortened address, bit.ly/eclipses for libraries. Pretty straightforward to remember, bit.ly/eclipses for libraries. And anyone can download this booklet, and many people are already starting to do that. As Jeff so kindly mentioned, my work partner, Dennis Schatz, and I have written a children's book explaining eclipses for young people. It's called When the Sun Goes Dark. It's published by the nonprofit National Science Teaching Association Press. And it's available. If you have children, grandchildren, friends who need to know about eclipses at the kids level, you can just find out more about it. You can go to bit.ly/sungoesdark, and it's available now for anyone who's interested in getting kids involved. It includes a lot of pictures and models that kids can play with using a tennis ball and a light to explain what happens during an eclipse and make it clear to them what they're observing when the eclipse actually happens. For teachers, as Jeff so kindly mentioned, we've put together a book of classroom activities from that same nonprofit press. And so if you're a teacher, you can go to bit.ly/solarsciencebook and get a copy of these activities that are appropriate for classroom use. I do want to mention that a friend of mine, astronomer Douglas Duncan at the University of Colorado, has invented something called Solar Snap, which is something you put over your cell phone, and then it has an app that you put on your cell phone, and that allows you to convert your cell phone to a safe device for taking pictures of the sun during eclipses or even when there's no eclipse. It's called Solar Snap. It's going to be available in many science stores from American Paper Optics, but just Google Solar Snap and you can find out more about it. Many people don't believe in regular photography anymore. They only believe in cell phone photography, so we wanted to make something available even for them to be able to take pictures of this once-in-a-lifetime event. We also have a booklet we've put together for teachers with activities and safe viewing guides and resources for teachers, and you can get that at bit.ly/eclipses for teachers. That's available through the National Science Teaching Association, which has a whole Eclipse section of their website gearing up. So lots and lots of people will see a partial eclipse of the sun, and they will need to do something to make it safe to look at it. You can glimpse it really fast, but that's no fun. You really want to be able to let your gaze linger, and to do that, you need to either protect your eyes with a certified pair of glasses from a reliable source, or you need to do something else. Now, I want to just mention before we get to safe viewing that it's likely that wherever the eclipse is total or annular, a lot of people will want to go see it, even that last minute. And so we found that there were traffic jams in 2017 that were especially bad after the eclipse, but were pretty bad before the eclipse. So if you're planning to go, make sure you think about traffic, and make sure you think about all the people who do everything in life at the last minute. Try not to be one of them if you really want to see the eclipse. Another issue that towns ran into was that huge crowds assembled in that pretty narrow path of the eclipse. The eclipse path is about 100, 125 miles wide, and little towns in that path were completely unprepared for the influx of people. And here's a particularly important example of how they needed to be prepared for an influx of sudden tourists. This year, we're working with the Office of Emergency Management and other federal agencies to try to warn states and towns and their emergency agencies about the eclipse and the possibility that huge crowds will descend. But if as you have some friends in the eclipse area, make sure you warn them about the fact that it may be a weird day for them during the time of the eclipse. This is not the first time we've had to deal with this. In addition to 2017, we can go back to 2018. This is a headline from the Denver Post. Thousands point glasses at sun to watch eclipse. Police enforce quiet so astronomers at university may make priceless observations. Movies to be taken. In 1918, that was a big deal. Movies to be taken. Throngs seek vantage points. So we've had lots of trouble then, and I predict we're going to have trouble this time too. That's why it's important to plan ahead. Now, how can you observe the eclipse if you are planning ahead? You can either use these glasses, which will be available from your local library. They'll be available at many science stores, at museum gift shops, through universities and colleges near you. Check out their stores if you are in a town where you don't immediately have a library that's participating. But again, we think most of these places will run out of eclipse glasses long before the eclipse actually happens. So it's important to get those glasses before the general public learns about the eclipses the last few days. But what can you do if you don't have a pair of glasses? You can take an image of the sun and reflect it onto a wall. The game is to take a hand mirror, cover it with cardboard, and make a small hole. Even if you're clumsy like me and the hole is not a perfect circle, it's okay. You just need a small hole. And then the game is to catch the light of the sun and reflect it onto a wall or a screen. use that mirror with the small hole showing the mirror part and make an image on a wall or a screen, then you will see the eclipse sun on that wall or screen. If you can't do that, you can also make a pinhole viewer or projector. You can take a piece of cardboard, put a hole in the middle. Some people like to put aluminum foil in the middle so that the hole will be made in the aluminum foil, which allows even a smaller and more precise pinhole, and then hold something like a white piece of paper or a screen away from that pinhole projector, and you get an image of the sun. So this is called indirect projection. And for many people, a mirror or a pinhole projector will be an easy and safe way to look at the image of the sun. Don't look at the sun. Reflect the image and look at the image. But if you don't have the skill to make such projectors, you probably have a wonderful astronomical device at home already, which is called a colander. You know what you wash pasta in? That consists of a whole series of pinholes through which the water flows down. All you need to do is to hold a colander up with your back to the sun and look at the shadow of the colander on the sidewalk or on a wall, and you'll see many, many images of the eclipse. And I can't tell you how many people amazed their neighbors in 2017 by going out into the street with a colander on their shoulder. And the neighbor said, "What's wrong with Mr. Jones? My goodness, he's got this colander on his shoulder." And then they came out and they got to see really nice pictures of the eclipse sun. So I recommend that you keep a colander handy. If you're able to have some equipment, a pair of binoculars, for example, you can cover one part of the binoculars and use the other lens as a projection lens, and then hold a white piece of paper, some kind of screen, some distance away from there, and get a nice image of the sun. Again, don't look at the sun through the binoculars. That'll really hurt your eyes. Even naked eye viewing hurts your eyes, so binoculars which concentrate light will really burn your eyes out. But if you use them as a projector, that's a safe way to view the eclipse. Now, if you're good friends with an amateur astronomer who's got a telescope and appropriate filters, and if they're around on the day of the eclipse, make sure you sign up to be at their house. We have many members of the Peninsula Astronomical Society here, our local amateur astronomy club, and I'm sure they will be having eclipse viewing and eclipse parties before the eclipse and perhaps during the eclipse, although during eclipses, many amateur astronomers want to get into the path. So they may not be here to show you the eclipse. But if you have a friend with a telescope, talk to them early about getting on the invitation list. There is a website that the American Astronomical Society has put together. It's eclipse.aas.org. Rick Feinberg, who was for many years their press officer, is an eclipse expert. And on this website, they have all the safety information. Where you can get glasses that are approved. In 2017, we had some glasses imported from China that did not have the appropriate material, were actually dangerous to look at. So you want to make sure that you have certified glasses. And this website, eclipse.aas.org, has all the latest information about where glasses are available, where certified glasses are available, who the reliable distributors are, etc., and also methods like the ones I've mentioned to view the eclipse without glasses. So that's another good place to look for good information about the eclipses. Well, I'm almost done. I want to just mention that if the eclipse is caused by a lineup of the sun, the moon, and the earth, you might ask, why don't we get an eclipse every month? After all, every month there comes a time when the sun, the moon, and the earth are lined up as the moon goes around the earth once a month. And so there will be the potential for an eclipse every month, but what we now understand is that the moon's orbit is actually tilted relative to our orbit around the sun. And because of the tilt of the moon's orbit, most months the moon is either above the sun or below the sun in the sky. It's not lined up with the sun. Only roughly every 6 months do we get an eclipse season. If you want to show this to a kid at home, hula hoops are a great way to demonstrate that. If you have one hula hoop, which is where the sun seems to go around us, another one where the moon seems to go around us, where the hula hoops cross every 6 months, that's when eclipses are possible, and we call that an eclipse season. Every 6 months or so, we have an eclipse season, and here's a little eclipse calendar showing you the past and the future of eclipse seasons. Over the course of history, most civilizations have seen eclipses, have marveled at eclipses, and have had prescriptions for eclipses. For example, in China and many parts of Asia, it was thought that during an eclipse a dragon was eating the sun, and the important thing to do was to frighten that dragon. So people would go outside and take pots and pans and other things and make a lot of noise, hit the pots and pans with a stick, and this enormous noise was supposed to frighten the dragon and make it get off the sun. And you know what? It worked every time. Some of these legends are still with us, and you might find people who make noise during an eclipse. From the science point of view, eclipses have been very exciting because we've gotten to know the atmosphere of the sun during such eclipses. We know that the sun has a multi-layer atmosphere made up of lighter materials than the sun, but also with a great deal of activity in them. And the study of the atmosphere of the sun really began and took off with our understanding and prediction of eclipses. And then I wanted to show you a picture of Einstein really happy, because Einstein made a prediction about space and time in one of his theories of relativity, which was so bizarre, even some scientists had trouble believing it. He said that when gravity was really strong, space and time warp in predictable ways. And the warping of space and time was something that was really a new idea. It was original with Einstein, and a lot of people had trouble accepting it and asked for proof. And Einstein realized that the Earth's gravity was too weak for much warping to take place near us, measurable warping. The Earth's gravity was just not enough. And the only thing in the neighborhood with enough gravity to warp space and time significantly enough to measure it with the right instruments was the sun. So Einstein said, if you could look at starlight going by the sun, and you could watch the path of starlight near the sun, the path of starlight near the sun would show a warping, a bending effect. There's a small technical problem seeing starlight going by the sun. What's that? Sun's a little bright. Normally, you can't see starlight going right next to the sun because the sun's glare completely eliminates any possibility of seeing stars. But Einstein was no dummy. He'd come to lectures like this, and he knew that during an eclipse, the moon could completely cover the sun. It would be dark in the middle of the day. The stars would come out, and you could measure the positions of the stars closest to the sun during that eclipse and see if their path was so warped that the stars would be out of place. After Einstein published this work in 1919, there was an eclipse of the sun visible from the coast of Africa. An international team of astronomers went to an island to make eclipse observations. It was cloudy that morning, as so often happens, but by a miracle, the sky cleared just as the eclipse was happening. They took a photo of the stars closest to the sun, and by gum, lights were all askew in the heavens, as the headline in the New York Times had it. Men of science, sorry, it was only men then, men of science more or less agog over results of eclipse observations. Einstein theory triumphs. And then the sentence I never get, stars not where they seemed or were calculated to be, but nobody need worry. Well, that's not right. They were exactly where they seemed to be. They were exactly where they were calculated to be. They just weren't where they were supposed to be. But we now know that it was the golf editor of the New York Times who got to write this headline. So you can forgive them. But this was news all around the world. During the eclipse, Einstein's theory was proven correct, and that was when Einstein became the most famous scientist in the world. It was this eclipse expedition in 1919 that cemented his public fame. So you never know when something good happens during eclipses. And if you don't catch this eclipse, I'm here to tell you that the next total eclipse, visible in the continental United States, will not be until August 12th, 2045. Some of us old folks can't wait that long. So this is the eclipse if you want to get to see a total eclipse. This is the one you want to catch. All right, well, I hope I've given you a lot to chew on in this lecture, and that you will have an opportunity to observe the eclipse. And what I want to wish you most of all is clear skies and happy eclipse viewing. Thank you very much.
I had a question. We all know that the moon's orbit is increasing and moving farther and farther away from the Earth. Sooner or later, I presume there's going to be a point at which a total eclipse is no longer possible. Has anybody actually calculated when that might be?
Yes. Thank you for bringing that up. In addition to being really smart in your choice of planets where you were born, you were also really smart in terms of the epoch during which you were born. Because we know that the sun and the earth, the moon and the earth are exchanging energy. And so slowly, over the course of long, long time, the moon is moving further and further away from the earth. And so the upshot of this is that in the past, the moon was too big to give us a really beautiful total eclipse. It was an over eclipse way in the past. And way in the future, it's going to be too small. The moon will be too far away during all of its orbit to ever give us a total eclipse. And so this is a really good time to be watching. Now, we're talking about millions and millions of years before this happens. So there's no need to take out eclipse insurance or any of that. But that will be the ultimate fate of the moon. It moves further and further away from us. All right, next question.
So the picture of the two eclipses that are coming up and pictures I've seen of previous eclipse paths, it seems like they should just go west to east, but they're going southwest to northeast and northwest to southeast and every direction possible. Why is that?
Yeah, why does the eclipse path not go exactly west to east? And that's because the Earth is curved, first of all, and because the orbits are not exactly lined up. So where you get the angle at which you get that shadow coming in is different for each eclipse.
Hi. In 2017, my husband and I went to a farm in Central Oregon to see the eclipse. And about 10 minutes before the eclipse started, it seemed like the environment around us went extremely quiet. The animals were quiet, no birds were singing. And I'm just wondering, was that our imagination, or is there something that the animals can sense ahead of time?
That's a great question. So what about animals and birds during an eclipse? And what the animals are sensing is that it's starting to be dark. And they associate dark with going back to the nest or going back to the barn, depending on where what kind of animals you're talking about. So it's usually their sign, as it gets darker and darker, that the end of the day is approaching. Except all their other biological markings don't say that. They don't feel like they've exhausted themselves in the course of a day and it's time to sleep. So animals get really confused. They say, is it night or is it day? Because the darkness is so impressive. When you get the total eclipse, it really does make the day go dark suddenly. It's so impressive that animals get all confused. And in 2017, we actually had a citizen science project where people were told to photograph and record the reactions of animals. They sent those reactions back to a central place. The California Academy of Sciences played a big role in this. And we got a lot of information about animal behavior and animal reactions for that eclipse. And that gives me a chance actually to mention that citizen science will be a big part of this eclipse as well. Citizen science is where we crowdsource science out to the public. A number of projects like this have been done already. In astronomy, we've actually had amateur astronomers, people in all walks of life, looking at data and discovering planets and doing other exciting things, classifying galaxies. And during this eclipse, we are going to be doing a number of citizen science projects. If you go to that website that the American Astronomical Society has, eclipse.aas.org, they have a whole section about citizen science projects you can participate in. One thing we want to do more precisely is to measure the rate at which darkness falls. And we're going to give light meters to people all around the country to see if the rate at which day turns into night is the same, how it goes, what it feels like in terms of human perception, and what it's actually like measuring it with instruments. So stay tuned. There might be some fun citizen science coming out of the eclipse. Next question.
Hi, I still have a stash of those glasses from 2017. Are they still good? Because the warning label says they have a 5-year expiration date.
Yeah, so this is a question we've been grappling with. Many people have leftover glasses from 2017. Are they safe to use? If they are certified glasses, if they have the ISO number on them, look for an ISO number. That's the certification from the people who deal with eyes and safety. If they have an ISO number on them, the material doesn't degrade. So it's safe, we think, in general, to use these glasses. The problem is that the plastic inside the glasses, the eye hole, is relatively delicate. And if you've stored them haphazardly, if they've scratched each other, if you had tennis balls and souvenirs in with them, then that may not be pristine material anymore. So you really need to check the glasses material to make sure that it's perfectly smooth, hasn't been damaged, no other material has fallen on them, they haven't had liquids on them. If you've stored them properly, they should be okay to use.
Thank you.
Thank you.
So you spent a lot of time talking about astronomy to the general public. I've gotten the impression from stories that I've heard that there's a lot of disinformation about eclipses. Somehow people think eclipses are dangerous. I mean, obviously they're dangerous if they're partial and you look at them without proper protection. But even like total eclipses, people get the idea that even a total eclipse is dangerous. And I was wondering if you had actually personally ever encountered that before.
Well, I haven't myself encountered it, but in many cultures, that was the reaction to the possibility of damaging your eyes. People said, what's the best way for people not to look up? Tell them it's dangerous. And so there are cultural traditions in which it's not okay to look at eclipses. A number of Native American groups have that as a cultural tradition, and there's been a lot of discussion of how we can delicately overcome the importance of listening to your elders and taking tradition seriously, but at the same time allowing them to see the eclipse safely. So there are many cultures where that has been passed down. It's also true that any piece of misinformation now travels at the speed of light around the world, thanks to social media. So it's very likely that there's going to be misinformation about the eclipses out there. All we scientists can do is to make available websites, information sites, talk to the media ourselves. And so there's going to be a lot of people trying to get good information out before October and before April to counteract any information that's misinformation. But, you know, the world is full of misinformation. When you have a government official like Kellyanne Conway talking about alternative facts, I don't know what you do about that. Facts are facts, folks. But thank you for asking. All right.
Hi. First of all, thank you for sharing that information about the eclipses. I'm a telescope operator, and I have my own private telescope with 8-inch reflector. And I noticed when I used my telescope to project the image onto like a white screen, I noticed that my wide field lens kind of got frosted in a way. Is there any way you could prevent doing that technique, using your telescope as a projector and not damage the lens itself, the eyepiece?
Yeah, and I'm not the right person to ask about that because now you're asking about specific optical setups. But I suspect that part of it has to do with what your lens is made of and the intensity of the rays that come through. But this is really not a question that's in my wheelhouse, so I'm sorry about that.
Oh, that's okay.
All right.
I thoroughly enjoyed the whole lecture here.
Thank you very much.
Okay. Back again for another question. Looking on the internet on the exact timing of a eclipse at a given city, I find sometimes conflicting information, and maybe you could steer me to the best place to look for precise timing, because you want to set up, you know, with a right to the minute.
Right. So before I answer the question, I want to recognize the questioner. The questioner is the person who has asked more questions more consistently at this lecture series than any other human being. This is Terry Turman, who's a member of the Peninsula Astronomical Society. And I want to recognize Terry as our most loyal questioner. And yes, it's true that because the calculations are pretty complicated, depending on how precisely you make the calculations, you might be off by a second or so. But for most people, that doesn't really matter. The websites that I mentioned, the American Astronomical Society website, the Great American Eclipse website, the website that time and date that has calculations, they're really pretty good. Those are pretty reliable if you want to get. Now, the most precise calculations are always done by the U.S. Naval Observatory. In the United States, the department of the government assigned to make calculations, official calculations, is the U.S. Naval Observatory. So you can always go to their website for the most reliable calculations. But I think you'll find that the ones I've given you pretty much agree in
websites for holes and predicting holes in the cloud cover.
Well, now there I can give you one. There is an eclipse weather expert. Imagine having that as your designation. You are the world's best eclipse weather expert. You've studied weather precisely for the problem of eclipses being clear. And the website is Eclipsophile, P-H-I-L-E, eclipsophile.com. Dr. Anderson is the web expert, the web eclipse expert.
How do you spell that?
Eclipsophile. Eclipse, then O, P-H-I-L-E, eclipsophile.com, has the best weather calculations. And in some of the websites I've given you, they will send you to Eclipsophile if you want better weather than what they're able to give you. So that's where I got some of the graphs that I showed you. All right, next question.
For the total eclipse, how fast would I need to run from Dallas to Montreal in order to keep watching it?
I knew someone was going to ask me that question, and I wrote down the speed of the eclipse. Let's see. Depending on where you are, the eclipse moves in Mexico at 1,560 miles per hour, in Indianapolis at 1995 miles per hour, and by the time you get to Newfoundland, it's moving at 4,400 miles per hour. These are all faster than the speed of sound, and your chances of running are almost nil. But thank you for asking. That's great. All right, we'll get to the last question.
I guess this is kind of more of just a little bit of a warning relative to the other guy's question about the telescope projection method. In 2017, I took a refractor telescope to the path of totality in the eclipse. And before, thankfully, I prepared because I ended up burning up 5 lenses in my telescope. And I just wanted to kind of provide that as a warning. If you're thinking of trying that method, you need to have the right filter on your telescope. You can take the filter off about 5 to 10 seconds before totality occurs, but if you leave it on longer than that, it's very likely you're going to burn your lenses. So I just thought I'd...
Thank you. That's a really important warning for people with instruments. Yes, so what a telescope does is it collects more light. That's how telescopes make distant galaxies visible. Distant galaxy sends very little light our way, and your eye simply can't register that small amount of light. But by collecting more light, telescopes concentrate the light and make a faint object visible. But at the same time, if you are now taking the sun, which is in a sense overloading you with light, and then concentrate that light, that can damage the internal optics, that can damage your telescope. So it's very important that you know what you're doing. There are filters for telescopes which filter out much of the light of the sun but still give you a good image, and those filters are something which you can buy. They're not cheap, but they allow you then to use your telescope during an eclipse or just have solar observing. The members of the Peninsula Astronomical Society every Saturday, I think, still have solar observing here at the Foothill College Observatory. Now, they take a lot of care to make sure that there are good filters solidly attached to their telescopes so that when you look through a telescope or get a projected image, it doesn't damage either your eye or the telescope. So that's a really important warning. I think we were going to have that be the last question. It looks like there's one more.
Very quick one.
Jeff, is that okay? Or?
The time, is it summer saving time on the table, or it just winter time or summer saving time? Because once I was checking one of astronomy website, and then it was like 15 years ago was something like Venus eclipse, and the time, and I came to watch it and I didn't see it because the time reported in my table was local time, not summer saving time, so I should have come 1 hour later.
Good, really good to point that out. In the charts that I've given you, that has all been figured out, so it's the appropriate time for that time of year for each locality. But if you go to some of the websites that are for technical people, they often give it to you in universal time, which you then need to convert to local time. And many lay people are confused by that. So the web information I've given you in the booklets that I've sent you to, those all already have those calculations made, and it's the appropriate time for that time of year for that particular locality. So thank you. Well, thank you all for coming out. Thank you for being part of this, and have a great eclipse.